we are now going to be talking about a rhombus, also known as a rhombi. So if you remember, if we scroll back, we started with this idea of a parallelogram. So parallelogram, and then day 5 was about a rectangle, which is one of the children of a parallelogram. The other child is known as a rhombus. Okay, so that's what day 6 is. So we're going to briefly go through the 5 parts of a parallelogram because a rhombus is a parallelogram with added features. So we have opposite angles are congruent, or opposite sides are congruent, So opposite sides are congruent. We have opposite angles are congruent. So those are those corner pieces. Opposite angles congruent. Now, what are these arrows? That means that they are parallel, which means that they never touch, okay? So if you see those pieces, that means parallel. This is the symbol for parallel, okay? Another feature that you want to be careful on is if they share a side like this, they add up to 180. And then the last one is they bisect, the diagonals bisect. That doesn't mean that all the diagonals are equal. It means that each diagonal is cut in half. So those are the parts of a parallelogram. A rhombus is a parallelogram with 4 congruent sides. So it has everything that the parallelogram has. It inherits all those properties, plus it has 4 congruent sides. Not just 2 pairs of congruent sides, now they are 4 congruent sides. It's a little crooked, nothing about the angles, just about the sides. The diagonals are also perpendicular, which means that they create a 90-degree angle. And the diagonals bisect the corner angles. Now that's a little bit, so it's just like bisect, right? The word bisect, it just means that these 2 angles, the angle is cut in half. So they are both worth the same amount. Okay, so we'll work these out based on what a rhombus is. Is a rectangle a parallelogram? Yes, it is. This is a true statement because it came from a parallelogram, okay? So parallelogram, it inherited all the traits. So yes, it is a parallelogram. Is a parallelogram always a rhombus? The word always is a little sketch, okay? So not always, because a parallelogram doesn't have to always be a rhombus. Sometimes it's a rectangle, and sometimes it's just a parallelogram. It doesn't have all the special features. Is a rhombus always a rectangle? No, they are not the same. They are siblings. They are not the same. It's like my sister and I. We are not the same, okay? Is a rhombus always a kite? Nope, they are not. A kite and a rhombus are never the same. Is a rhombus always a parallelogram? Let's think about this. A rhombus came from a parallelogram, so that is true. So we have true, false, and true. All right, let's talk about these next ones. Which one has all the sides being congruent? Well, that's what we just talked about, which is a rhombus. All angles being congruent, that's what you learned yesterday. That is a rectangle. When are the diagonals congruent? That's also a rectangle. Okay, so when it has 90-degree angle corners, it also means the diagonals are congruent. Okay, opposite angles are congruent. Well, that's a parallelogram. Well, what is the children of a parallelogram? It also has to be a rectangle and a rhombus. Okay, so if it's a parallelogram, the children of the parallelogram also inherit those traits. The last one, sum of interior angles. Well, that's any 4-sided shape, and that would be all of them. All of them are 4-sided. Therefore, the inner angles add up to 360. All right, now let's get into the nitty-gritty because that's what's going to be on our upcoming assessments. A rhombus. If it's a rhombus, what can I do? Well, all the sides are congruent. I have a 90-degree angle, and I can do some work. So AD is 11. BC is 11. CD is 11. Bada bing. Here we go. All the sides are congruent. Therefore, they're all 11. CED. So CED is this one right here. Okay. Well, I know that diagonals are congruent in a rhombus. So CED is 90 degrees. BAE. BAE. What about this one right here? How can I find out what that one is worth? Okay. Well, let's see here. Well, if these 2 sides are parallel, okay, and I have this angle right here, These are called alternate interior. So this is also 60 degrees, BAE. And EDC, let's look where this one is, EDC. How do I find out what this one is worth? Well, if I have 90 degrees and if I have 60 degrees and I have this triangle right here, all triangles add up to 180 degrees. So I have a 90 degree, a 60 degree, and I don't know what this one is. So 90 plus 60, subtract from 180, is 30 degrees. So please follow along as I go through this. All right. So again, alternate interior angles are equal. In a triangle, those add up to 180. So therefore, that last one was 30 degrees. Okay, be very careful when you are reading these out. I always draw them in so I know what I'm talking about. JML, ooh, that's this big angle right here, JML. This whole thing together is 70 degrees, okay? What is JKM? Ooh, so across the way, I'm looking for just that part. I didn't say JKL, I said JKM. All right, so a rhombus. A diagonal cuts these angles in half. So if the whole thing is 70, what's half of 70? Well, that means each of these chunks is 35 degrees. Well, because a rhombus is also a parallelogram tells me it inherited the property of opposite angles are congruent. So if that whole nugget is 70 degrees, this whole angle is also 70 degrees. What's half of 70? Well, that is 35 degrees. So again, 35 degrees is for each of these sections because a rhombus cuts angles in half. All right, last one. That's it, guys. All right, let's look at what we're doing over here. So I have diagonals. So I have PK, I have PK right here and KY right here. So these two make up a diagonal. So I know that they bisect, okay? That means that they are going to be equal to each other, and I'm going to solve. Okay, so I'm going to subtract 4y and add 14. So I subtracted 4y and I got 3. I added 14 because it's the opposite, and I got 15. I'm going to divide by 3, and y equals 5. Well, none of my answers are finding out what the y is. I have to plug it back in. So I'm going to plug in 5 into each of these and see if I get the same answer, because I should get the same answer for both of them. So I have 20 plus 1 is 21. 35 minus 14. 35 minus 14 is also 21. So if I want to find out the whole thing, I have 21 plus 21, which equals 42. So again, please be careful. Look at the shape. What are they asking for? Okay, the next one is asking for this whole diagonal. Okay, we're going to do the same song and dance. So I have those two. I'm going to make them equal to each other. I'm going to solve and plug it back in. So I subtracted 2x and I got regular, and I got just 1x. I added 1 and I got 7. I plugged 7 back in. 21 minus 1 is 20. 14 plus 6 is 20. 20 plus 20 is 40. So if you notice, the diagonals are not congruent. A rhombus, the diagonals just bisect because that's the trait of a parallelogram. All right, YKZ, what is this nugget? Well, a rhombus has a perpendicular diagonal. So that means all the inside angles, the diagonal angles, are 90 degrees. All right, last song and dance is YZ. So YZ is a corner piece, okay? It's one of the sides, all right? So let me draw what I'm looking at here. So this triangle right here, I have a 90 degrees, and I know that KY was 21 and KZ was 20. So I made a a right triangle, and I did Pythagorean theorem. A squared plus B squared equals C squared. I'm looking for this C because it's across the way from the 90 degrees. So this blue triangle, this blue one I highlighted, is over here. Okay? I found out what each of these parts were worth by going back up here. KY right here. KY was 21. And I found out that KZ right here was 20. So I grabbed those two pieces and I found out that C was 29. 29, the length was 29. Okay? So to reiterate, a rhombus, all the sides are congruent. The diagonals create a 90-degree angle. So then you're going to have some Pythagorean theorem. And the diagonals bisect and make those corner pieces cut in half. Okay? Please look through all your notes, and we'll see you next time. Have a good day.